Okay, worksheet number 2. The first thing we're going to have to try to do is we're going to have to try to express as a single fraction the exact value of the sine of 75. So if you're given a question like this and they want the exact value, there's only one way you're really going to get that, guys. It's not with a calculator. You have to remember this 30, 60, 90 right triangle, 1, 2, radical 3. You're also going to have to remember this 45, 45, 90, 1, 1, square root of 2. So both of those need to be memorized. Okay, so using these angles, 45, 30, and 60, we have to come up with, and also unit circle, right? There's my unit circle. Oops, let me move it over. This point is 1, 0. This point is 0, 1. This point, negative 1, 0, and this point, 0, negative 1. And knowing that cosine is that first coordinate and sine is that second coordinate. You know, these are the things that you're going to have memorized coming in. Might as well finish it. Quadrant 1, 2, 3, and 4, A, S, T, C. So you need all that. Okay? For this question, though, you really need those two triangles. So using the degree measures of 45, 30, and 60, we got to come up with 75. And the way you do it is you keep the trig function the same, and you just write 75 as the sum of two angles that you can find the exact value of. There it is. And then what you're going to do is, remember, anytime you're taking the sine, cosine, tangent, and the angles are not just an angle, but the sum, the difference, or you're multiplying it by 2, or you're multiplying it by a half, it's an identity. So you go to the formula sheet, you start taking a look at your identities. Here's sine A plus B, cosine, here are all of your formulas. Okay? This is the sum, this is the difference. Over here you have the double angle identity, down here you have the half angle identities. All these is just read the formula and write it down. So this is the one I'm going to use because I wrote it as the sine of the sum of two angles. So I'm going to write that down. Sine of A plus B is equal to, copying this formula, sine A cosine B plus cosine A sine B. Okay, once you have that formula down, we're done with the sheet. I'm just going to now substitute in. My A is going to be 45 and my B is going to be 30. So now this becomes sine of A, which is 45, cosine of B, which is 30, plus cosine of A, which is 45, sine of B, which is 30. All right, I need to come up with these values. All right, sine of 45. Sine of 45 is going to be 1 over the square root of 2. And when you make that nice, that's the square root of 2 over 2. Cosine of 30 is going to be adjacent over hypotenuse, square root of 3 over 2. Cosine of 45 is going to be 1 over the square root of 2. And when you make that nice, it's radical 2 over 2. And then the sine of 30 is going to be opposite over hypotenuse, which is 1/2. We multiply these together by multiplying the denominators together, then the numerators together. Over here, multiplying the denominators together, multiplying the numerators together. And then we want to express this as one fraction. The denominator is the same. The numerator is simply going to be the square root of 6 plus the square root of 2. There's the exact value of the sine of 75 degrees. All right, next question on worksheet number 2. We want to express the exact value of cosecant 60 with a rational denominator. So keep cosecant 60. We're supposed to remember that cosecant 60 is really equal to 1 over the sine of 60. Well, to find out what the sine of 60 is, remember, go to your triangles. Here they are, here's 60. The sine of 60 is opposite over hypotenuse. So it's going to be 1 over the square root of 3 over 2. Stay, change, flip, and multiply. Alright, and then we want to simplify that, because what it says here is we want a rational denominator. That just simply means make sure you don't have a radical in the denominator anymore. That's 2 square roots of 3 over 3. There's your exact value. Question number 29 at the bottom from worksheet 2. Now they're asking us, find to the nearest tenth of a degree the angle whose measure is 2.5 radians. So 2.5 radians, to go from radian measure to degree measure, we multiply that by 180 over pi. Alright, so again, if you wanted to, calculator can help you here. So we're going to go 2.5 times 180, and we're going to get 450, and then we're going to divide that by pi, and we get 143.23. They want to the nearest tenth of a degree, so bringing that back over, 143.23 becomes 143.2 degrees. And that concludes worksheet number 2.